Good morning, guys. Welcome to this session. Welcome, everyone. Warm greetings from Mercy Technologies. So, this is our third class in this week, actually. And we are going to see again on linked list only today. Till yesterday, we have seen how to traverse a linked list, how to find the length of the linked list, how to insert in the linked list. Insert has three different cases: insert first, insert last, and insert at a particular index. Now today we are going to see delete operation. Similar to insert, delete operation also has three cases: delete first, delete last, and delete at a particular index, right? So let's see what is our agenda for today. Agenda is, as you have pointed out yesterday, we'll be dry running the code, the one that we have done yesterday. Yesterday we have run the biggest problem in our course until now. So I'll be showing you what exactly it is and how we can, how to dry run that and how to understand that. And the second, after we are done with that, we'll be going to the deletion program. And deletion program also would be similar to the insertion program. So in the sense, if you are able to understand this, then you are able to understand the deletion. And if you are able to understand these two, which means you are able to understand the basic problems in linked list, right? Let me go back and show you how do we write on that, right? Yesterday if we see these were linked list insert. So this is the program that we have written. So it has what? Insert first, insert last, and then insert at a particular index, right? Insert at a particular index. Okay. So here what I would like to do is, I told you that we have done step by step everything, and we were able to see the output as well, right? First, let me try to run this program for you and show you what the output is. Okay, so here we have the following input in our main method. Let me open up the whiteboard as well. So what is the input saying? Let me change the naming convention also. 16, and here there is 13, node 13, and node 7, right? Node 7. And here, let's say I'm doing this one, head.next 16.next should be node 13, right? Node 13.next should be node 7, and then let's say I'm removing this one. Okay, I'm removing this one and I'm inserting something at the index, whatever. So I'm doing this one. Let me try to run this program for you. Right, 16, 13, 16, 13, 7, and at this particular index, what is this index? Let me run it again. So index, it's starting from 0 in our case. So when I say insert at particular index called 2, 16 is at index 0, 13 at index 1, 1 at index 2, once again 0, 1, 2, right? 0, 1, 2. And what is this? At particular index called 2, which means after 13, you insert a value called 1, right? Value called 1. And finally, you're able to see that this is the output. Let's say I'm not doing this operation. What I'm doing, I'm just commenting that operation, right? Again, I'm trying to run the same thing. So here, if you see, I did not insert at a particular thing. The actual traversal is giving me an output of 16, 13, and 7. So let me try to write the same thing in my whiteboard as well. So what is it saying? It's saying the following thing. So I'm drawing a simple linked list. So this is 16, 13, and 7. This is 13, and this is 7, right? So what is this? This is head, and these are like links to the next nodes, and this is marking the end of the linked list. So what is expected? So this is index 0, this is index 1, this is index 2, right? What is the length of the linked list? Length is equal to 3, right? Length of the linked list is 3. So what is your requirement at a particular index? At a particular index called 2, at a particular index called 2, 0, 1, 2, right? Somewhere over here, at this particular point, or after that. So which means, see, this is the guys, like index can be 0, index can be 1. This all follows in our naming convention and the way we are coding. As of here, what I'm trying to do is at a particular index, I'm trying to insert a value. What is that inserting value? I'm trying to insert value called 1 at an index called 2, right? So let's say value called 1. I need to create a new node called 1, right? And it should be inserted, right? Let's say there should be a link. The next of this 1 should become this, right? And then next of this node should become this. What happens? Eventually, this link should fade away. This link should fade away. This is the actual requirement, right? This is the actual requirement. For this only we started coding yesterday. For this only we started coding yesterday, right? For this only we started coding yesterday. So if this is our requirement, let me try to show what and all were there as part of our code yesterday, and so that we can actually understand what we did. So this is the code, guys. I just copied that in the notepad plus so that I can snip that properly and I can paste it and show you what exactly it is. So I've taken a screenshot of the same code, right? Taken a screenshot of the same code, I'm copying that, and I'm pasting that in our whiteboard. Right? So if you see, or let me bring it like this. This is the code that we have written yesterday, guys. Okay. And we have just run the code as well, right? We have just run the code as well. So let me try to write on this code for you. This is our input 16, 13, 16, 13, and 7, and we need to insert somewhere over here. We need to insert it over here. Okay. So let's try to see the code step by step and understand what exactly we have written, right? So here, as part of our line number 1, what we did, we have written a method called insert at index. The index is given somewhere over here. Let's say the index, the main method, the index is called as 2. In the main method, we have taken the index as 2. Let me uncomment this one. Okay. So that's what we got in this method as well. And finally, here as part of line number 2, what we did, we got the length of the linked list. We have already written a method. We try to reuse that. This is modularization. I told you guys, we'll be seeing a different approach of code today, but this is modularization. I'm able to get the length of the linked list as line number 2. So what is that length? Length is 3, right? Again, at line number 3, I'm taking this reference variable. That's fine. We can use it. And now here we are seeing the base conditions, guys. What are these base conditions? If index is greater than length. If index is greater than length, what is the index that you are passing? Let's say index that you are passing. Let's say index that you are passing here is 2. Let's say, right? Index that you are passing is 2, and if index is greater than length, is index greater than length? 2 is greater than 3? No, it's not possible. So this base condition we are not achieving. We are not coming into, right? And then if index is equal to 0, which means you are trying to insert somewhere over here only. So, but that is not the case for us. So we are skipping this insert first also. And then if index is equal to length, length is 3, and index is 2. So we are skipping this one also. We are not inserting at first. We are not inserting at last. So what are we doing? We are inserting at a particular index, right? So that's why we came to this line number 15 by crossing all the base conditions. So what is line number 15 doing? It is taking a variable called p and it is assigning that to head, right? P. What is p? P is actually this right now. P is actually this. And now we are taking a node called q and we are creating that. What is q? Q is nothing but this. We have created a new node and we have taken 1, right? We have initialized that with 1. What is our x here? X is nothing but 1, right? That is our actual input which we intended. If you see on line number 65, we are saying what is the input that we are giving? The input that we are giving is with 1, right? Is with 1. So here, let's say what happened, we have created a node called x at line number 16. So, and then we are having a new variable called count equal to 1, right? Count is equal to 1. And here, while p dot next is not equal to null, node r is equal to p dot next. So we'll try to see it step by step. So at line number 18, p dot next is not equal to null. What is p here? P here is 16. P dot next is not equal to null. No, p dot next is 3, right? And so what we are doing, node r is equal to p dot next. So let's see what is r. R is nothing but p dot next. So what is r? R is nothing but this one, right? R is here. Now, if index is equal to count, no, it's not the case because we already checked that. And then p dot next is equal to q. What is p dot next now? P dot next. We have something. So here, this if condition we are not going into because this condition is not meeting, right? Index is equal to count, right? Index is equal to count. What is index? Index is the count for that is 1 and the index that we are intending is 2, right? Index is 2. So that's why this if condition is not met. We came to line number 25. Then we are saying p is equal to p dot next, right? We are saying p is equal to p dot next, which means p is not here right now. P is here right now, right? P is here right now. Okay. So we came here and saying count plus plus p is equal to p dot next, and we are saying count plus plus. So now the count value is 2, right? The first iteration is done. Again, we are coming back. To this part, line number 18. So again, we are checking p dot next is not equal to null. What is p now? P is at 3 right now. So p dot next is not equal to null. That's fine. Now r is equal to p dot next. What is r? R is nothing but 3 right now. So as per line number 19, we are moving r to the next node, right? R is now here. R is not here. R is here, right? If index is equal to count, yes, this condition is met now. Index is equal to count. So we are coming inside, and what we are doing, p dot next is equal to q. What is p dot next? Here is p, and p dot next is q. So here is p. We have already written q. What we are saying, p dot next is equal to q. So we are enabling this link, right? This link. Until now, p dot next is this, but here we are not doing this. We are saying p dot next is equal to q. What is the next path? We are doing q dot next is equal to r. Okay, what is this q? Q we already have. This q dot next, initially it was null, right? Initially it was null. Now we are not doing that. We are saying q dot next is equal to r. But what is r? R we already have. We have stored that in our previous iteration, and we are saying that. And since this condition is met, what we are doing, we are saying break. So which means you're saying you came to the condition, you are able to insert it properly, you break, and automatically this link is also gone. So in that way, when you see at the end, this index, this node is not deleted. The only thing that is deleted is this link, right? This link. So by seeing this, what we can say, we can say that we are able to insert at a particular index, right? This is how it is, guys. I'm able to dry run this code for you now just by having code handy with me. So let's say you're not able to write how to code, or if you're not able to understand how you should start coding, right? So in that case, you take small examples. First, you really why did we take a pointer called r over here? Anyone can get it out. So why did we take? The only reason is if we are saying p dot next is equal to q, which means we are losing this link, right? We are losing this link. So we should not lose this link. That is why I'm already storing this in a reference variable called R, and finally that R is coming handy when this condition is met. So in that way we are able to insert at a particular index as required in the diagram, right? Okay, okay. So this is what it is, guys. I just want to ask if you are able to understand this. So yes, I got yes from everyone. So here it is. Understanding this code is very important. The reason why it is very important is here in this small piece of code, just by taking, say, as I told you yesterday only, I told you if you go and search, you'll be getting very minimum or small solutions, right? Maybe the same operation they are doing in very few number of lines of code, but here our intention is not actually solving it in number of lines of code which are very minimal, but actually understanding. So today deletion, I'll be showing you how we solve that in minimalistic lines. That is called as minimalistic approach, guys. We'll be seeing the minimalistic approach today, right? But here understanding this, trying to dry run, trying to actually get the output is very important, right? The same code, if you observe, I just modified the node, a single linked list node, etc, and I've given that as part of yesterday's notes. You can take that, open the link that I have given you yesterday, and finally you can start exploring. You should be able to run that program straight away. This program looks big, but it's not big. Just by understanding its theory or how it is happening internally, you should be in a position to play with it, right? With this point, guys, I'm going to the next part of our today's agenda. So what is our today's agenda saying? Our today's agenda is saying we need to learn deletion, right? We need to learn deletion, right? So what is the coding standard that we are trying to approach or understand today? The coding standard is minimalistic approach. Yesterday we have seen modularization. Today we are seeing minimalistic approach. So what is this minimalistic approach? Minimalistic approach is nothing but, even though when there is a requirement or there is a chance of bringing it to different methods and writing the code in a clean, in a big, in a more understandable way, there are requirements where you need to make the code as precise as possible. Okay, for example, let's say it is as part of an interview, or it is as part of like, for example, let's say interviewer asks you to write that on the board. You cannot just fill up the whole board on with what you call, I mean, that's called as a whiteboarding interview, guys. Whiteboard, I'm able to see the software of whiteboard, but when you go for interviews of big product companies, they'd like to ask you to write code, right? So if you start filling up the whole board with this piece of code, then there's no point. I mean, there's nothing for the interviewer to ask you, right? So you should make the code as minimal as possible. But when they give you a test or something, when they ask you to write it on a piece of paper and they give that as a test to you, you should make sure that you're following this coding conventions, etc. So it's all up to you. Nothing is wrong, nothing is right. So it's all up to you. I just want to teach you both the approaches so that I'm coming with the different approach today, right? So let's try to learn what exactly is deletion of the linked list. I'll take the same example. A better example, or we can say the same example. So here there is a linked list called 1, right? 2, and then 3, right? So there are, here it is marking it as head, and these are the links to the next link, and then finally this is null. So as I told you, deletion is of 3 cases. First thing is for delete first. Second thing is delete last, and the third thing is delete at index, right? So the same thing, what I want to say is the cases 1 and 2, what we did yesterday as part of our yesterday's programming, we have done insertion first, insertion last as two different methods, and we try to use the same at delete at an index, the same thing we did over here, right? If you see, as part of our insert at last, we try to use this method insert first, and we are trying to use this method insert last. So based on these conditions, what we can conclude is insert first and insert last is also a type of inserting at a particular index. Just by looking at the index, we are in a position to say, are we inserting that at first or are we inserting that at last, right? The same thing, if we need to use the minimalistic approach, we need not use those methods, but internally in our code itself, we can tweak something and find this is our first, this is our last, this kind of things we can find. So let's say, how do we delete first? Okay, how do we delete first? In our same example, let's say I'm trying to delete first, which means my program should delete this and say that my head is starting from here, right? Head is starting from here, and finally this is what it says. So this part should be totally gone, right? So for this, what you can do, you can straight away say, let's say this is p, right, and this is p dot next, right? So what you can say, say straight away, if p is not equal to null and p dot next is not equal to null, what you can say, return p dot next, right? When you do something like this, a simple code like this, what you're checking if p is not equal to null, no. If p dot next is not equal to null, yeah, that's fine, because p dot next is also having some value equal to. What you're checking, you are returning p dot next. So here you are saying the head, I mean, you are returning from your program that p dot next is the actual head for you, which means you are discarding that. Deletion doesn't mean that you're actually deleting the linked list going inside the memory and saying, yes, I'm deleting. It's not like that. I told you, if we lose the access to our head, which means we are lost somewhere in the memory. Right? So it shouldn't be that case, guys. Like, I'm just, what am I doing? I'm just moving or modifying head so that the first node is gone somewhere in the memory, which means we are deleting it. What happens when you have deleted? People can argue that I actually did not delete this. So how you can say that this line that I have written is able to delete something? So there is some concept called, there are various programming languages, guys. We have taken Java as our program of instruction for this course, but there are various other languages. In languages like Java, there is something called garbage collection. Okay, garbage collection. So don't get confused with this word garbage collection. It's nothing but this is something which goes on internally inside JVM, and what it does, it tries to find out if there is any node or any object which is not having any reference, which means actually people are trying to or intending to delete it, but they haven't deleted that. Okay, which means it is not accessed by any pointer, any reference variable. Is there any object of that sort in the heap memory? It will check, and if yes, it will delete, right? So actually what you're trying to do, you're saying you're not pointing this head anymore, and you're saying you're pointing this to it, which means nobody is even caring if this exists or not, right? Nobody is even caring if this node exists or not. So it means you're discarding that, and the deletion is taken care by Java by using this garbage collection, right? This is how it is, guys. This is how simple it is. Okay, I just want to ask if you are able to actually understand deletion at first, because I just written this pseudo code over here. I did not write the actual code. This is also important, guys. So just want to ask if you are able to understand delete first. I'll be showing you the actual code. Now we have seen how we delete the head, right? Now let's go to the second part. Let me try to discard this first for you. Let me try to discard this code first for you. Okay, this is fine. Let me move this like this. Okay, so what is the second? Delete at last, right? Delete at last. delete at a particular index which is last. So how do you go about? Let's say you need to let's say you have all this, the p is already there, I mean the same linked list is already there. Let me try to write it once more. So something like this. So something like this is already there. What is that? 1, 2, 3, right? So something like this is already there. What you are saying that delete last. So what is last over here? Last is nothing but this, right? Last is nothing but this. You have to delete this node. So let's see, how do we write code for this? How do we write code for this without even trying to write the code? I'm thinking how to write code for this. This is called as thinking loudly. Okay, thinking loudly. So what you have to do, obviously what you have to do is you have to iterate from here until here. You have to iterate from here until here like this, and at the end you have to delete it, right? At the end you have to delete it. Let's say I write something like this: while p is not equal to null, right? I say p is equal to p dot next. This is my iteration. This is my iteration. Finally with this what happens? With this what happens? Let's say my p is over here, and finally you're saying p is not equal to null. You're saying p is equal to p dot next. Now the p is this. Now again p is equal to p dot next. Now the p is this. Finally you came and the p dot next is null. So p is actually here, right? P is actually here. P is actually here. But what you have to do, you have to delete this. You have to delete this. When you have to delete this, your p actually should be here. Okay, your p actually should be here. When your p is actually here, you can say p dot next is equal to null. P dot next is equal to null. When you say p dot next is equal to null, which means this is getting discarded, right? This is getting discarded. So that's what I say, when p is actually not here but here, which means your program would be working, right? So which means you need to tweak something in this. You need to tweak something in this method, right? Here what I'm saying, while p is not equal to null, I'm saying, instead of saying p is not equal to null, I'm saying p dot next. I'm tweaking the code. While p dot next is not equal to null, I'm trying to see. Let me try run this code again. While p dot next is not equal to null, here let's see the p is actually present over here right now. Okay, I'm trying to do with the modified code. I'm trying to try run this. P is over here. I'm checking p dot next is not equal to null. Yes, p dot next is not equal to null. It's coming, and then you're saying p is equal to p dot next. So you came here, right? Now p is this, right? P is not this right now. So again, while p dot next is not equal to null, p dot next is not equal to null, right? P dot next, the p dot next is not equal to null. That's fine. Again you came here, and you're saying p is equal to p dot next, right? P dot next, yeah. P dot next. So again this is causing you a problem. The reason why it is causing you a problem is, again, the p is over here only. If you try to dry run this, you are trying to do the same thing. So here let me tweak it once more. I'm checking next dot next. So I'm checking while p dot next is not equal to null. Then if I'm trying to do this, let me try to dry run this once more. My p is present over here right now. I'm checking p dot next is not equal to null. P dot next is what? 2. P dot next is what? 3, right? So this is not the case. So that's why I came to this loop, and I'm saying p is equal to p dot next. Now the p becomes this, right? P becomes this. Now again I'm checking p dot next. What is p dot next? P dot next is 3. Next dot next is what? It is null, right? It is null. So that's why I'm not even coming to this condition. This condition is ignored, and here we are saying p actually is present here, right? P is actually present here right now. P is actually present here right now. So at this particular point, I'm skipping the condition. I'm saying p dot next is equal to null. P dot next is equal to null. But actually, what is p? P is at 2 right now, and p dot next, what am I trying to do? I'm trying to delete this or discard this, right? Discard this. So in that way, my condition should be like this: p while p dot next is not equal to null, p is equal to p dot next. At the end, what I'm trying to do, p dot next is equal to null. When you're saying p dot next is equal to null, you are actually meaning that your P is one node behind the actual last node, and you're saying that P dot next is null, which means you're saying I don't want the last node and I'm assigning that to null, which means garbage collector will come and it will take that away. So in that way, what happens? My only this list is remaining, the other list is discarded. This is how you have to take examples. You have to take examples and try to figure out just by try to dry run in a small way and try to figure out what actual code you need to write, and then you need to start writing the code, right? This is how the deletion, this is a pseudo code for deletion, guys. This is how you think loudly also. You're able to understand the delete at last, guys? Just want to ask. So with this we are able to do two cases, right? What are those two cases? Deletion at first and deletion at last. Deletion at first and deletion at last. So what is the last case? Last case, as we have written over here, is delete at a particular index, right? Delete at a particular index. Again, it's the same. We have to pass some index, try to see the different cases and try to see if it actually works or not. This different things, right? Now I'll be teaching you how to delete at a particular index, but I told you deleting at a particular index also comes to this delete first and delete last. These two cases, these two conditions also would be covered in deleting at a particular index. Today, as part of our class, what we will be doing is I'll be showing you this program in Eclipse. I'll be trying or making you run that in HackerRank, and maybe show you how do we debug or how do we actually find if we are making any mistakes in HackerRank, and then we'll be wrapping up this session. Good that people have followed this session until now. And now we are going to see delete last program. I told you we are using minimalistic approach, right? Yesterday for linked list insert, I've taken one method. Again, they have one method. I tried using these two methods, and finally I'm trying to write the logic for insert at a particular index. So it's not the case today. Today, what am I trying to do? I'm trying to handle all those cases here itself, right? This is the only code that I've written now. And this code should be able to make me to delete the node at a particular index. So what did I do? Before doing that, I'd like to show you that we have taken an example, something like this: 16 13 7, right? 16 13 7, 16 13 7, and we are trying to delete the node at an index called 2. Let me try to run this to you. Okay, so 16 and 13. Let me not call this method. First, I'll show you what are the nodes that are present. Okay, I'm commenting the line number 32. I'm not deleting anything. Let me try to run this code and show you what is the actual input we are having. We are having an actual input of 16 13 and 7, right? 16 13 and 7, 0 1 2. 16 has an index of 0, 13 has an index of 1, 7 has an index of 2. What am I trying to do over here? I'm saying, as line number 32 says, you delete at a particular index, which is 2 in our case. So when I try to run that again, my output is showing only 16 and 13, because at particular index called 3, we are deleting it, right? We are deleting it. So I'll tell you what is the code that I'm written over here. So as part of our discussion previously, what are the first things that we need to do as part of our coding is we need to handle the base cases, right? We need to handle the base cases. So what are the base cases, guys? The base cases. So what are the base cases, guys? The base cases are these two, right? So base cases is head is equal to null, which means actually you do not have any linked list and you cannot delete anything in that linked list. So in that case, I'm returning null. All right. In that case, I'm returning null. So this is first base case. What is this first base case saying? If there is no linked list existing at all, then you try to return null. So you can even like use exceptions over here. I can say this can never happen. I can print, why are you trying to insert something in a null linked list? Or I can print something that that is irrelevant to me, right? The first base case is done. What is the second base case? If head dot next is equal to null, head dot next is equal to null, then return null. So what is this base case saying? We can understand just by seeing, we can understand that, let's say we have something like this. We have a node something like this. Our linked list is having just this, right? One, and that's it. This is head and this is null. So which means the length of our linked list is what? The length of the linked list is only one. So which means when you are trying to delete that particular index, which means there is no linked list existing now, right? Linked list is not existing now. So that is why there is only one node that is existing, and I'm deleting that also. What I can say, I can directly say return null. The reason why I can say return null is because I'm not even like the single node that is existing, I'm trying to delete it. When I try to delete it, actually what I'm saying, this is called a soft delete, right? This is called a soft delete. So you are deleting it not by removing that from memory, but you're saying it is equal to null, so that nobody is pointing to that. And in background, there will be garbage collector which will come constantly and check anything is null, anything is null. So it will go and check the objects which are null. It will go and grab all those objects and it will delete it by itself. So we as a programmer need not do that. But if you are trying to do this as part of C++, or if you are trying to do it in some other language which doesn't have this garbage collector internally, so you have to take care of that deletion part also. But if you are trying to write it in C#, Java, this kind of programming languages, the deletion is actually taken care, right? Even if you're trying to write it in C language, so the deletion you have to take care, the pointers and all, you have to take care of all those. That is a little bit hard to I mean, it's not hard to learn, but I mean, it's that's not the actual point of learning data structure. So that's why I have chosen Java, so that these kind of things are taken care in the background. Okay, so this is our second base case that we have written from line number 8 to 10. So what is the second base case? If the length of the linked list is only one, which means head dot next is equal to null, then you are trying to return null, right? At this particular point, right, I'll take the same example, or I'll try to take the same example, 16 13 7, right? 16 13 7. I'm trying to dry run this, or maybe I can do one thing. I can actually copy this code and try to show you what exactly is happening, right? Let me take a snip of this. Let's do it. Let's see. So here is our code. So what is our code saying? What is our code saying? The code is saying that the first case, I mean, this one we have already seen. This is our first base case. This is our first base case. This is done. And this is second base case. This is done. And the third base case, actually we are starting our code from here. So what did I do over here is, as I told you previously, we should be taking care of different things. So I told you here I'm straight away using single linked list case, because this program we can straight away copy and run that in HackerRank. Okay, so that it becomes easier for us. So I've taken single linked list and it is head, and as part of let's say, what is our input? Our input in the main method is something like this. The input in the main method 16 13 7, right? 16 13 7. Okay, so here it is 16 13 7. We are pointing it null. Okay, this is head. Okay, this is head. So what we did, this is our input for us, and first we have taken a single linked list node, and we have taken a reference variable called p, right? We have taken a reference variable called p. And what is p? P is equal to head dot next. P is equal to head dot next. What is our head? Actually, head is actually present over here, right? So what is p? As part of our initialization logic, I'm saying P is this, right? P is this. So I'm just commenting that to be current, okay? Current node, right? I've taken one more node called Q and I'm initializing that to head, right? This is Q right now. Let me try to use a different color. So this is Q, this is P, and this is Q, right? So if position is equal to 0, return P. So what am I trying to do? This is position 0, position 1, position 2, which means index. When I mean position, HackerRank is using that as a position. Maybe I thought you as an index, or let's try to use the same convention, the position. So what is the position? The position here is 0, position here is 1, position here is 2. What you're trying to do, you're trying to delete at position called 2, right? Position called 2. So here what you're trying to check, if position is equal to 0, which means you're trying to delete which is at the first, right? You're trying to delete at this particular position, so what you're trying to do, you're trying to return P, which means you should discard this part, right? You should discard this part, and you are returning. This is also one base condition. I'll tell you why I have written this part here. Maybe when you solve the HackerRank solution, you'll be getting to know. So here, as part of line number 16, I'm taking one more variable, which I'm naming it as count, right? Count equal to what? Count equal to 1, right? So here, p.next is not equal to null and count is less than position. Count is equal to 1 right now. And what is our position? Position is equal to 2, right? Position is equal to 2 as per our main method here on line number 32. Position is equal to 2, right? So what am I trying to do? While p.next is not equal to null, but what is actually p? P is this. P.next is what? 7. It's not equal to null. And count is less than position. What is count? Count is equal to 1 and position is equal to 2. Position is equal to 2. So I'm trying to do this. What am I saying? P is equal to q.next, right? What is the new p value right now? P's value is q.next, which means p is not this, but p is this, right? P is this. I'm even modifying what? I'm modifying the q's value also. Q is equal to q.next. What is q? What is q? Q is modifying its value. Q.next is what? This q, right? Now q is over here and p is over here. So what am I trying to do? I'm trying to even increment the count at line number 20. So I'm making it as 2, right? I'm making it as 2. Again, it's coming back to the while condition. But this condition, count is less than position. What is count now? Count is 2 and position is 2. This is broken. So that's why this while loop is broken right now, right? This is done. Now we are saying q.next is equal to p.next. What is q.next? Q.next is what? q.next, which means this pointer, q.next is this pointer. It is saying the p.next, but what is p.next? P.next is null actually, right? So which means you're saying q.next is p.next, right? So in that way, you are discarding this node. So which means after line number 22, you're saying q.next is equal to p.next, q.next is p.next, and finally you're returning head. So what is head here? This is very important. Why you need to return head? Because you are doing some operation over here. You're deleting something over here, which doesn't mean you need to modify the head or something. I told you we should never modify the head. Okay. And then we are returning the head so that when somebody tries to iterate this again, so he'll come here and next he'll come to this node and then he'll check what is the next of this one. So he says instead of going to 7, he'll straight away come to null because what we did as part of our line number 22, we tried to tweak this input and finally say that this is the output for us, right? With a small example, I think you should be able to understand what exactly we tried doing here. Please message if you are able to understand, guys. Now we are able to understand what exactly we are trying to do for deleting at a particular index. If you see this code, guys, in the same code, instead of using different methods, I've used only this piece of code and tried to handle all the different cases. Let's say you want to handle even more cases. As I told you, what you have to do, you take examples, maybe take an example of 5, length is equal to 5. You take example, you try to dry run it like this. You try to see if everything is working fine or not. Then you try to run that in Eclipse. then maybe you try to solve that in HackerRank straight away, whatever. But the thing that I want to tell right now is this dry running is very important, because only this will tell us, is our actual logic correct or not? Are we trying to write the correct logic or not? If you are not able to do this part, which means which means that we are not able to code it properly. This doesn't come straight away after this class or something, guys. Like, you need to practice, but this is not very hard. Like, once you're able to do this, once you're able to dry run this two codes, the inserted a particular position, and what do you call, deleted a particular position, then you are good to go. I mean, this is the total base of data structures. When you're trying to, when you're very clear, crystal clear with this approaches, which means you will be understanding data structures in a very proper way. This is the place where most of people lag, guys. If you like, if you see, people say that this code is very tough to understand, etc., etc. But the thing is, just by taking examples, we ourselves are able to write this code. Yesterday also I did the same thing. Just by taking examples, I was able to write the code just in front of you. And maybe you'll be feeling this is not that hard. Only thing is, the practice is something that that matters a lot. Right now, what I'd like to do is, I'm coming straight away into the HackerRank problem. So this is the HackerRank problem. People have at least understood what HackerRank is, what it's trying to do, etc., etc. So I'd like to do this problem just in front of you and make you understand that in a even better way. So delete node, it has so much of description. I'm not going to read all this. So what it is saying, it is having a sample input like this. What it says, sample input is of length 8. So 1, 2, 3, 4, 5, 6, 7, 8. So from 20 until 9, the length is 8, and at an index of 3. So what is index of 3? It is 0, 1, 2, 3, which means 19, right? 19. So what it is trying to do, it is having a length of 8, and at the index of 3, which is at 19, you should delete this 19. Which means after 2, 19 should be gone, and then 7 should come. After 2, 19 should be gone, and 7 should come. This is the actual output that they are trying to make us. So I told you the same code I copied from Eclipse. And I'm trying to, and I just pasted that here. I just pasted that in our HackerRank solution. Okay. So let me try to run this for you. Okay. It's already done. I mean, just to show you. Okay. This is how it's processing. So let's say we'll take a sample test case of 1. So what is a sample test case of 1 saying? So it is saying the length of the input is 4, 11, 9, 2, and 9, 11, 9, 2, and 9. This is the input. So you have something like this. You have a position called 1. This is 0, and this is 1. You have to remove this 9. Okay, you have to remove this 2, because 0, 1, and 2, right? You have to remove this 2, right? So after you remove this 2, as per the input that's given, so output should be something like this. The same thing we have done, guys. Just I tried to dry run this code. I try to explain you what exactly I've done. So the same thing I copied and I pasted here. You can straight away, instead of typing that in Eclipse, or you can straight away even do that here also. It's all up to you, guys. This all comes only with the practice, right? So I've done that, and I'm able to run this code. Let's say I want to test that with a particular input. Okay, I'm trying to test that with a particular input. For example, I can click this test with custom input. Let's say the length of my linked list is 4. Okay, I'm trying to have values of 1, 2, 3, and 4. So what am I trying to do? Let's say I'm trying to delete this number called 3, right? This is delete this number called 3. So that way, what am I trying to do? Index of 1, index 0, 1, 2. So I'm giving the index as 2, right? When I give the index as 2, which means you're trying to delete 3, because the index is starting from, or the position is starting from 0. Let me try to run this code. Okay, the output should be 1, 2, and 4. Let me try to see if this happens or not. Okay, this is how it is. The output is 1, 2, 4. The reason why it is 1, 2, 4 is at index of 2, I'm trying to delete this 3. And what is it? What is this causing this output? It's the code that we have written, right? It's the code that we have written. So guys, there are some situations where people say do not print anything. So here, what the code they'll be say, yeah, do not print anything on studio out or console, right? When they explicitly specify this, then maybe when you try to print something, it may give you an error. So let me try to experiment that also. Here, what am I saying? System dot println. So I'm trying to do something like this, right? Trying to do something like this and saying I just want to know what is the p value right now. Okay, p is equal to, right? I'm saying p dot data. Okay, I'm trying to do something like this, p dot data, right? I'm trying to do something like this, p dot data. So let's say I'm running my code. Okay, right? Debug output, this is called as debugging output. This is how you debug. I told you we'll be debugging in Eclipse, right? So we can even debug inside HackerRank also. How? Let's say you got confused of what will be the value of this one at this particular point, or let's say what is this, what is that. You can have some debug points like this, right? You can have some debug points like this, and then you can run the code. So that output, the debug output and your output, this will not, make any difference. This will not make any difference. So by this debug output is 3. I just showed you how do we debug in HackerRank. So let's say with this, I'm able to run the code properly. I'm removing this. Okay, I'm trying to run it again. When I try to run it again, it is saying the debug output is something like this, right? That's fine. Now I'm submitting here. Only there are 2 test cases. Now let's say I'm submitting this code. So there are total of 8 test cases, and all the 8 test cases are passed to the program that we have given, right? And this program has given us 5 points. So it's like this, guys. This is how it is. Just try to take small examples, try to write code like this, try to dry run that, try to convert your pseudo code into the actual code just by going to HackerRank, or maybe you try to do that in Eclipse, and finally you'll become a master just by practice, right? Guys, you understood how did I solve that in HackerRank? Okay, so guys, with this we can wrap up today's session. So what did we actually do as part of today's session? We have seen a minimalistic approach. Okay, today our agenda was to find out the revision. We were able to dry run the code. We were able to see the deletion. All the 3 cases of deletion were handled in the same method itself, and we went and we coded that in the Eclipse, and we saw that in the HackerRank as well. So with this, guys, let me try to wrap up this session.